Hi, this is Joe from the Math Perimeter, where I help to make mathematics accessible, engaging, and approachable through various forms of content, including articles, infographics, videos, and email newsletters. This video is part 3 of a 3-part series where I cover advanced uses of the substitution rule. For more information about this topic, please refer to the article linked in the description. In this video, we will evaluate the integral of e to the 2x plus 2 secant squared of 2x dx, the integral of 1 over x minus 1 over x plus 1 squared dx, and the integral of ln x over x plus 2x e to the x squared plus 1 dx. We will begin by evaluating the integral of e to the 2x plus 2 secant squared of 2x dx. We begin by letting u equals 2x. The differential is then du equals 2 dx. Dividing both sides of the differential by 2 gives 1/2 du equals dx. Substituting into the integral gives the integral of 1/2 times e to the u plus 2 secant squared of u du. Distributing the 1/2 gives us the integral of 1/2 e to the u plus secant squared of u du. Applying the sum rule then gives the integral of 1/2 e to the u du plus the integral of secant squared of u du. Applying the constant multiple rule, we obtain 1/2 times the integral of e to the u du plus the integral of secant squared of u du. Integrating, we get 1/2 e to the u plus tangent of u plus c. Back substituting, we arrive at a final answer of 1/2 e to the 2x plus tangent of 2x plus c. Next, we evaluate the integral of 1 over x minus 1 over x plus 1 squared dx. Applying the sum rule gives the integral of 1 over x dx minus the integral of 1 over x plus 1 squared dx. To evaluate the second integral, we let u equals x plus 1. The differential is then du equals dx. Substituting into the second integral, we obtain the integral of 1 over x dx minus the integral of 1 over u squared du. Rewriting the second integral in terms of negative exponents gives the integral of 1 over x dx minus the integral of u to the negative 2 du. Integrating gives L an absolute value of x plus u to the negative 1 plus c. Rewriting the second term using positive exponents, we obtain L an absolute value of x plus 1 over u plus c. Back substituting, we arrive at a final answer of L an absolute value of x plus 1 over x plus 1 plus c. Lastly, we evaluate the integral of ln of x all over x plus 2x e to the x squared plus 1 dx. We begin by applying the sum rule to obtain the integral of ln of x all over x dx plus the integral of 2x e to the x squared plus 1 dx. To evaluate the first integral, we let u equals ln of x. The differential is then du equals 1 over x dx. To evaluate the second integral, we let v equals x squared plus 1. Our differential is then dv equals 2x dx. Plugging in these substitutions, we obtain the integral of u du plus the integral of e to the v dv. Integrating gives us 1/2 u squared plus e to the v plus c. Back substituting, we arrive at a final answer of 1/2 ln squared of x plus e to the x squared plus 1 plus c. Thank you for watching. I hope you enjoyed the video. Please like and subscribe. Thank you. See you next time.